Today we're going to discuss how to solve word problems that involve exponential functions. This really involves two steps: identifying the initial value, which we'll substitute as a, and finding the rate of growth or decay, which we'll then use to find the growth or decay factor. So what you want to have out is this page that you have 134 so that you can look at it while we do the word problems, because I'm just going through these steps. Okay, so we need to identify our initial value and then find our growth or decay factor from the percentage increase or decrease. And we'll plug that in as B. So let's read the first one. The world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.26%. Just reading that. What is my population, which is my variable? What is the number I'm starting at? I'm starting at 6.08 billion. So that's going to be my A value. Then if I see I have a percentage increase, so my part A is telling me to find the growth factor for the world population. Usually they're not going to break it down and give me this step, so I need to know to do this. But for this first one, they told us. When we need to change from a percentage to the factor, that's where we need to change it to a decimal first. So 1.26%. Think about it. If I have 1 cent, that means I have $0.01. But I don't just have 0.01, I also have this 2 and 6 hanging out at the end. So I have to add that. And what we've really done is moved our decimal to the left twice and just added a 0 there, okay? So that is changing it to a decimal. Now since it's increasing, that means I need to do 1 plus 0.0126, which would give me 1.0126. Part B says, suppose the rate of increase continues to be 1.26%. This means my base is good how it is. Write a function to model the world population. Remember, function just means equation. Okay, it's just a special type of equation. So my equation is going to be y equals something times something to the x, and I just have to fill it in. Look at where we started. My initial value is 6.08. Then I found my base in part A, which is 1 point, if my decimal will work, there we go, 0.126, and I'm raising that to the x. Now let's see what type of question they will actually ask. Let x be the number of years past the year 2000. Find the world population in 2010. So think, how long has passed from 2000 to 2010? 10 years. So that's asking me to plug in 10 for x. In other words, evaluate y equals 6.08 times 1.0126 to the 10th. The 10th is in an exponent. And tomorrow, when you come to class, we'll talk about how to type that in the computer or the calculator. For now, we'll just write it down. Going to example 2. A computer valued at $6,500, so that's what I'm starting at. That's my A. Depreciates, that's an important word. That means it's going to decrease at the rate of 14.3% per year. And part A shows us more what we're going to see. Write a function that models the value of the computer. So that means I need to write down my initial value, which is 6,500, and I need to find my decay factor. So that means I need to do 1 minus, since it says depreciates, my 14.3 as a decimal. If I have 14 cents, that means I have $0.14, but I also have the 0.3 so it needs to be 0.143. Once again, all I've done is move my decimal to the left twice. So I need to subtract 0.143. And when I do that, I get 0.847. Sorry. I was doing that one in my head. 557. Okay, so that means my base is 0.857. Make sure your decimal's lower than mine. I don't know why it's so high. Okay, there we go. Now, it says find the value of the computer after 3 years. That means plug in 3 for x. In other words, y equals 6,500 times 0.857 to the third power. Once again, we will figure this out tomorrow on the calculator, but it's going to be as simple as typing this in. Last example for tonight. The population of a certain animal species decreases at a rate of 3.5% per year. So I know I'm going to do 1 minus something. You have counted 80 animals in the habitat you are studying. So that's my initial value. It's how many I saw when I started. Write a function that models the change in animal population. So I need to have y equals my initial value, which is a, and then I'm going to multiply it to my base and raise it to the x. So first I need to change this to a decimal. If I have 3 cents, that would be $0.03, but I have this 0.5, so I need to just add that at the end. Once again, what am I doing? I'm taking 3.5 and moving my decimal to the left twice. So 0.035. That's how I'm getting this. And if I subtract that, I should get 0.965. Okay? I didn't quite have 4 cents off. I had 3.5 cents off. So this makes sense. Part B, we're going to talk about how to do tomorrow using a graph, but notice it's giving me my y, it's giving me 15, so I'm going to be using my intersect function on my calculator to find out when y is 15, what is my x value? So it's a little different than plugging something in for x. All right, if you want to get a jump start for tomorrow, I would go through and try writing equations for the rest of the problems. Otherwise, make sure you're studying page 132 and 133, going between rate and factor, and rate. And I'll see you tomorrow.